Alright, this video is going to focus on analyzing real-world examples with statistics. And as you can see at the beginning of this video, I just have a quick little snapshot of how to use the calculator for doing this analysis. I'm going to focus mainly on the calculator, but you can use the chart. If you want to see that in the previous video, you can. Alright, so let's take a look at an example. Let's say we have 5,000 eggs from a particular chicken distributor, and they have an average weight of 50 grams and a standard deviation of 5 grams. What with sizes normally distributed? This is an important statement. Without this statement, you can't really analyze it statistically. So, let's take a look at the first problem. What is the probability of an egg being laid with a weight below 45 grams? And how about 42 grams? Well, to do the first problem, below 45 grams, what we're going to do is we set up a normal curve with the mean. So the mean of this is 50. So you see I put 50 here, and standard deviation is 5 grams. So I added 5 going up to draw this, and I subtracted 5 going down. And so from there, what I'm going to do is I'm going to think about what it means to be below 45. Well, 45 is actually one of the members of the empirical rule. It's this negative standard deviation, 1 deviation. So you could just add up the little pieces. You could add up the fact that this is over here, this has a value, this has a value, and this has a value. You can just add those values up from the empirical rule. Otherwise, I could convert it to a z-score and use the calculator. So the way I do that is I take the actual amount, which is 45, and that equals a z-score of -1. Okay, so what I'm going to do is I'm going to go into my calculator, and I'm going to use second distribution number 2 to find the value for this. And then once I do that, again, the calculator is trying to do, again, we're looking at this domain, so the domain is negative infinity to -1. You can leave that in there, you can put in -1,000 if you want. And then you go to -1, and then it will tell you the probability. So the probability here is 0.5186. So that's the answer. What about this next question right here, where I have something below 42 grams? Well, 42 grams, unlike 45, is not an standard deviation, and that's going to make it a z-score. So I come over here to 42, and this is going to want to find this. It's going to be slightly smaller than the one we found earlier. And so what I do is I take 42. 42 is the x element in the z-score. I subtract off the mean. Okay, the mean is 50, and then I divide by the standard deviation. So the standard deviation is 5, and that comes out to -1.6. You can use your calculator. Make sure you use parentheses or the fraction feature. So to do the fraction feature, you hit alpha F1. You go to the fraction mode, and you just would type in 42 minus 50, and then divide by 5, and that will give you the number. Now, unfortunately, this is probably going to come out as a fraction because it's in fraction mode. So if you want to find the decimal, you just do -8 divided by 5 and hit enter, and it tells you it's -1.6. And since I'm trying to find average weights below this, it does say below, I'm going to go to second distribution number 2, and then I'm going to type that in as -1,000, again for negative infinity to -1.6. Alright, so -1.6 is going to be smaller, and you can see now that I get the value of 0.054799 as the area. Alright, so let's take a look at percentages of things that are above. So again, you can see what I'm doing here is I have a similar situation where I have 60 grams, and 60 grams is simply going to be above the average, because the average is 50, so 60 is here. So if I want to find this amount, once above, you can see that's going to be a small number. And again, using the calculator, I just converted this to its z-score. You can just count, right? So if you were to count this using the z-score, it's simply going to be 1, so that's 0, then 1, and then 2. So this is a z-score of 2. And then from there, what I did, right, it's just a z-score of 2, so I just put it in the calculator using the things we've already talked about. Okay, and it gave me that value. But this one wants percentage. So at one's percentage, I have to simply move the decimal place over by multiplying by 100, so the percentage is 2.275%. So if I look at the next example in here, I have 53 grams. And 53 grams, again, that's not a z-score. I mean, that is not a standard deviation. It's going to be a z-score. So I have to actually calculate this. Notice I have 53 here, minus my average, okay, divided by my standard deviation, and that comes out to 0.6. And then again, the way I'm going to type that in is, since it's above, is I'm going to go second distribution, right? So second distribution, number 2, and I'm going to put this in. This is the domain, so if you look at the domain, it is 0.53 to infinity. So converting 0.53 to a z-score is 0, sorry, when I said 0.53 I meant 53. So I'm going to convert 53 to a z-score of 0.6, and then I go to infinity and I put 1,000 in for infinity, because you can't put you can't put infinity in the calculator. So that'll give me this value of 0.27, which then I would multiply by 100 to get the percentage, because the problem does ask for percentage, so 27.4253%. Alright, so let's take a look at one that would be between. So between, you guessed it, you're going to the first problem will be simply z-scores, and you can see that I have a z-score of here to here, and so to go between this, I'm just going to put in from negative 2 to 2, and this one I just did with the empirical rule. Negative 2 to 2, that's going to be 0.95 according to the empirical rule. And so this one is interesting because this one asks me to find the number of eggs. This one wants the actual quantity of eggs. Well, this comes from doing a problem from middle school percentage problems. It says in the problem that there are 5,000 eggs. So if I take 5,000 and I multiply that times this decimal, 0.95 times 5,000 will yield the actual number of eggs. So that's how you take the actual number and turn it into a quantity that's used in the real world. Okay, to do one with a z-score, you would have to find the z-score twice. So I have 0.47, which would be about here-ish, and then I have 53, which would be about here-ish. So to find that area in here, I'm going to convert each to a z-score. So 47 converted to a z-score is negative 0.06, and 53 converted to a z-score is 0.6. Okay, you can find these two values on the chart and subtract the larger from the smaller one. Okay, the chart is in a separate video, or you can go into your calculator and go to second distribution, okay, number 2, and then you can put the lower limit of negative 0.6 in, and then put in the upper limit of 0.6. I made a little typo. I'm going to fix it. Please make sure you check your own typos. It's very frustrating for students when they're doing everything right, but they just make a simple typo. So we put that in. That tells us the area between those is 0.451. That is the area, but again, if I want to know the actual value of how many eggs, which is what it's asking, I take the quantity of eggs, which is 5,000, and I multiply this decimal times 5,000, and it tells me that I get 2,257 eggs. Alright, so here's an interesting question. Let's say you had a random egg that you just took out of a carton. So I have a carton of eggs, okay, and I pull mine out from the store and it's 56 grams. What is the percentile? Well, this problem is pretty simple. I just take my 56, I subtract off my mean, okay, and then I divide by my standard deviation to convert to a z-score. I take this z-score and I use the calculator to find the percentage. But keep in mind, when I think about the normal curve, a percentage is take the normal curve and then go to 1.2 and find everything below it. So I am going to, when I type it in the calculator, so I'm trying to find below, I am going to use negative 1,000 in the calculator and then go to 1.2. And so this number converted to a percentile is 88.49th percentile. And that's a value like you would see when you get your SAT report back about how well you did. Alright, let's look at one more example. So let's say I have adult narwhals, and they're in the wild, and they have a horn length of approximately 13 feet on average, and they have a standard deviation of 12 inches. Notice the unit problem here. So I'm going to have to convert the length in feet into inches. Okay, so what is the probability of finding an adult narwhal that has a horn length between 1.5 140 and 180. What I'm going to do here is just find the z-score. Okay, so I find that z-score by taking this x value and subtracting the mean and then dividing by the standard deviation, and it gives me this z-score. I do the same thing with the other one, so I take 180, I subtract off the mean, I divide by the standard deviation, and that gives me a value of 2. To find what is between these two values, I can use my chart or I can use the calculator. It is just faster to use the calculator, so I did. I put in my lower limit of negative 1.3 here and my upper limit of 2 here, and it gave me this value. Now, be very careful. Is this what they're asking? Let's go see. The question is find the probability, so I'm good. Probability and area are the same thing. Alright, so the next question, okay, then you can see that I wrote it out. It's actually a typo because I had changed this from a percentage earlier, so this one should be 0.88603 is the probability. And it's important to understand that that value, that decimal point, matters in a problem like this because you have to pay attention. Am I asking about percentage or am I asking about area? So the next one is if there's 120,000 narwhals off the coast of Norway, so 120,000 narwhals, this is going to ask me to actually find a quantity. So notice I just gave you the same two values. So looking at this problem, what I did was I just took the values previously that were 140 and 180, and that we already know that percentage from the problem above, that decimal I mean, and to turn this into a actual quantity, I take those narwhals and I multiply it, and that'll tell me the number of narwhals. So 106,324 would be expected to have horn lengths of this length. Now this is confusing for students because students remember 7th or 8th grade or 6th grade percentages, and they're like, that's supposed to be 88.64%, but remember, 88.64% would have to be turned into a decimal to actually do math. There is no percent button on your calculator. Percents have to be divided by 100, and question A was already in that format, so I didn't have to do anything to it to be able to do question B. Alright, so C is, if you find a narwhal with a horn length of 16.8 feet, what is its standard deviation and what percentile does it lie in or fall into? So notice this is in feet, so I had to convert it right here. I had to convert it to inches. I then put that value in here for x. Okay, then I have my mean of 156 inches, and I have my standard deviation of 12 inches. That gives me a z-score of 3.8. And when I say percentile, keep in mind percentile here is saying find the lower limit. Find all this below 3.8. So again, I go into my calculator, I put in negative 1,000, I put in 3.8, and it gives me that it's the 99.93 percentile because I have to then convert this to a decimal here. So that means that's an exceptional specimen in the wild. It has one of the longest horns ever found is what that means. So on the SAT, if you're in the 99th percentile, it's basically impossible to say you're in the 100th percentile because that's just basically unheard of. So be very happy if you ever see something like a 99th percentile, especially if you get a 99.9 percentile. Alright, so here's the next thing, which is going to convert from a percentile to a z-score. So let's say you have a colleague and they claim, hey look, I found something in the 78th percentile. What does that mean as a z-score? So what you do is you go to second variables, you go to choice 3, and then you put the area in. So I'll run through that with you. So you take second distribution, choice 3, then you put the area. You can't put 78 here, you have to put 0.78. You have to turn the percentile into an area. You hit enter, you stay on left because percentile by definition is left. You can't hit enter here, which is kind of strange. You have to hit down and hit paste, and then you go and you find that that is a z-score of 0.77. Okay, so you can see that I have that. You could also use the chart in reverse, as I mentioned on a previous video. Hope these real life problems help and help make understand what statistics is and how it is used.